So today's discussion is a continuation of volume from our last lesson, but we're going to look at a couple of different shapes. We are going to address cones and pyramids. So the volume concept is the same. We're talking about a three-dimensional measurement, and we're filling a shape. Now, really, truly, the formula for volume is really, truly the same. We have to be thinking about the area of our base multiplied by the height, and then any adjustments if we're not filling a complete shape. So we're going to talk a little bit about the concept of cones first. So to sketch a cone, I kind of do a little oval as opposed to a circle. It's implied to be a circle, but I draw an oval so we kind of have a concept of depth. And then we're going to put a point up here, top middle, and we're going to connect it to the edges of our oval. And I always think of like a party hat or an ice cream cone when I'm thinking about the volume of a cone. So for us, the base of a cone is going to be a circle. So that area is pi r squared. So I'm going to put in a center point on our circle, and I'm going to label r. And then we need to multiply by our height, which is going to be perpendicular to our radius. So we've got our height. And then this is what's a little bit weird, is this is the same formula for the volume of a cylinder. The area of the circle rising up to the top. But a cylinder or a can, that's going to fit more in it than a cone, because a cone has everything on the edges shaved down to meet that point. So what we have to do when we find the volume of a cone is we have to multiply it by 1/3 to remove all of that volume around the edge of the cone on the outside where that point would be. So we're going to take 1/3 times pi r squared h. So we're going to do an example on how to find the volume of a cone. So I'm going to put my circle up here on the top. I'm going to put my point underneath, connect the sides to the edges of my circle or oval. So let's pretend this is an ice cream cone, and we're going to fill it. I don't know, I like my ice cream cones filled with like the hard fudge, the chocolate, so that the ice cream doesn't drip down through the bottom of the cone. Very picky. I have standards when it comes to my ice cream cones. So we're going to fill this with that fudge that's going to get all nice and hard and crunchy. And not just a coating, that's cheap, we're not going to do that. We're going to fill it with fudge. So we're going to find the volume of this. So when I think about a cone, I'm going to say that this is about 4 inches tall. When I think about a cone in terms of diameter, now note that word, I just said diameter. I'm going to make my diameter 3 inches. And our job is to find our volume. Well, I'm literally trying to find out how much fudge we're going to fill into this cone. So to do that, we need to take pi r squared times our height with a 1/3 out in front. Because without the 1/3, that's the volume of a cylinder. We aren't getting that much fudge. Well, I can do the 1/3 and the pi. We have to be very careful with this concept of radius. Right now, our diameter is 3. So we have to convert that into a radius of 1.5. We have to cut that in half. So that 1.5 is going to be squared as our radius times our height of 4. We're definitely going to have to do a little bit of rounding on this volume problem. So I'm going to put my calculator up so you guys can kind of see it, tilt it with the glare. But we're going to have, let's see, 1/3. So I use probably way too many parentheses. I'm going to put my 1/3 in parentheses. And then my pi button times 1.5 squared. I'm going to close that because that's the area of our base or the area of the circle. And then times 4 for our height. And yep, we're definitely going to have some decimals here. So we're looking at 9.4 inches cubed. And that is the volume of the fudge that we are going to fill into this cone. And again, that 1/3 is removing all of that volume that would fill if we were talking about a cylinder or a can. Do you guys have any questions on the volume of a cone? Okay. So let's talk about another one. Let's talk about a pyramid. So there are tons of different types of pyramids that we could address. We are specifically going to address rectangular pyramids. And what that means is we're going to have a rectangular base. So our base is going to be a rectangle, square, could be a square as well. Those are the only ones that we are going to address in this class. So when it comes to sketching these, as you guys know, I'm not the best at this. So I'm going to start off with just a nice rectangle, parallelogram, quadrilateral. And I'm going to put a point up and center. And I'm going to connect to the front, bottom, and then dash the back sides. So I'm hoping you can envision a pyramid. The ones on your assignment, the ones on a test are professionally drawn. You'll be able to see the stinking pyramid. So I'm going to tell you that the base of this pyramid, the rectangle, is 8 centimeters by 6 centimeters. And then the height is coming from that top point, that peak, perpendicular down to that rectangle base. So the volume of a pyramid is also going to have a 1/3 because we're not using all of the volume around the edges of that vertex. We have to shave it off, thus the 1/3 times the area of the base times the height. So it's the same formula as a cone, it's just the area of the base is different. For us, we need to think about the area of the base as our rectangle. So this particular base is 8 by 6. And I'm going to tell you that the height is 10 centimeters. Sometimes I can't fit it in the picture, so I'm going to draw a little arrow out. So for our volume, 1/3 times base, area of the base, times the height. Well, we are looking at 160 centimeters cubed. for volume. Questions on the volume of a pyramid.